2004 private ones. The question reads, a class consists of 30 boys and 20 girls. That means in the particular class there were 30 boys and 30 girls in that particular class. Now they said 60% of the boys. That means not all the boys can swim in this class. Only 60% of the boys and 40% of the girls. And 40% of the girls, 40% of the girls can swim. A boy and a girl are chosen at random. Find the probability that both of them can swim. Now let us analyze them one after the other. A class consists of 30 boys. So you say number of boys according to them, we have 30 of them. Then the number of girls in that class, you say number of girls that are there, 20 of them. Now 40% of the boys and 60% of the boys and 40% of the girls can swim. You say percentage of boys that swim. Percentage of the boys that swim, they said 60%. And here percentage of the girls that swim. According to them, 40% of the girls can swim conveniently. Now they presented them in percentages. Let us now look at the actual figures that this 60% is represented. Out of 30, they said 60% of the 30 boys can swim. Again, out of the 20 girls, they said 40% of them can swim. Let us get the actual figures. Now we say number of boys that can swim. Number of boys that can swim. Now we want to look at the number of boys that can swim. Have in mind that percentages are expressed over 100. So if I have 60% here, percentages are always expressed by 100. You divide by 100. 60% divided by 100 of the number of boys. And the number of boys is 30. So I'll cancel this one and cancel this 0. I cancel this, I cancel this. I have 6 times 3, that is 18. So that means the number of boys that can swim is 18. Out of 30 boys, 18 of them can swim. Let us come to number of girls that can swim. Number of girls that can swim. Out of 20, they said 40% can swim. So 40% mean we divide 40 by 100. And then we now have to multiply that by the number of girls there. I will cancel this, I cancel this, I cancel the zeros. So I have 4 times 2 is 8. So that means out of the 20 girls, 8 of them can swim. We now move. A boy and a girl are choosing at random. They are now going to select one boy and one girl from that particular class. You find the probability that both of them can swim. Here the word both is used. Since both is used, it tells you that it is independent probability. That means the swimming ability of the boy has nothing to do with the swimming ability of the girl. So if that is the case, anytime this thing, one event cannot terminate or interfere with the other event, we call the independent event. So here it is an independent case. So since it is independent, we multiply them. Now let us go. Find the probability that both of them can swim. So the probability of both of them swimming, it will be the probability of the boys that can swim multiplied by the probability of the girls that can swim. That is what we are looking at. The probability of the boys that can swim multiplied by the probability of the girls that can swim. We are multiplying because both is used. That means the occurrence of one event has nothing to do with the other. So if the probability of a boy that can swim here, the required event is boy, that is 18 boys can swim, divided by the total number of boys there is 30. We multiply that by the probability for a girl to swim here. There are 8 girls that can swim. That is the required figure we need, is those that can swim, and there are 8 of them. You divide that by the total number of girls in that particular class, that is 20. We can try to cancel some terms here. If we want to cancel here, 2 can go here, that will be 15 times. 2 can go here 4 times. 4 can go here 1, 4 can go into 20. That will give us 5 times that way. Now there will be a number that can go into 18 and 15. 3 can go into 18 6 times. 3 can go into 15 5 times. So you get 6 up here. 6 times 1 is 6. You divide that by 5 times 5, 25. So you can access this one by searching on YouTube, by just searching for Momo Kini on YouTube, and you can get the live videos as well. Thank you and God bless you.